Hi, dear students. In this video, we're going to see the process scheduling concept, first come, first serve approach. So, as the name itself says, first come, first serve approach. Here, a number of processes arrive to the system, and every system will not be given to the CPU. Instead of that, all the process enters to ready queue. Whichever the process arrive first, that process will be allocated with CPU. Remaining process must wait in a ready queue in such a way that the already allocated process must complete the execution voluntarily. After the completion of execution, process release the control of the CPU back to the OS. Then remaining process which are in ready queue will get an opportunity to go for the execution. So as you know, the life cycle of a process, first come first serve approach is non-preemptive in nature. What is non-preemptive and preemptive? Non-preemptive is nothing but once CPU is allocated to the system process, it will be not taken back until the execution completes. This is non-preemptive. Preemptive is nothing but if a process is already allotted with CPU, in next couple of time, control of the CPU can be taken and be allocated to the next process. That is called as preemptive in nature. Let us consider the example given below, where you have four processes P1, P2, P3, P4 with the bus time 24 milliseconds, 4, 6, and 8. But also arrival time is given. Process will arrive to the system in the order 1, 2, 3, 4. Now we need to write a Gantt chart for the same. So as you all of you know, this is represented by a Gantt chart. Here you have a ready queue, CPU allocation, and time in milliseconds. So now we start to write the Gantt chart. As you all aware of that, so at the time 0, process P1 will enter into the system. Okay, then P1 will be selected for the execution. So checking the table, as given in the table, the time required for P1 to complete the execution is 24 milliseconds. So here, since it is a non-preemptive, process 1 complete the execution by getting 24 milliseconds. Okay, at this, now the time becomes 24. At this 24 millisecond, all the process arrived to the ready or ready to the execution. Now P1 is already completed the execution. Now opportunity will be given to P2. So what is the time required for P2? 4 minutes. So again, it will be allotted. So it will be added 24 plus 4, 28 milliseconds. So P2 also successfully completed the execution. Next, P3 will enter into the system. P3 requires 6 milliseconds. It is also going to complete. So 28 plus 6, 34. So P3 will be terminated, and another last process in the ready queue, that is P4. It requires 8 milliseconds to execute. It will be given the opportunity to execute. Now 34 plus 8. It will become 40. So you can also verify whether the Gantt chart written is correct or not by verifying the last number in the Gantt chart and the sum of the bus time. So both should be equal. Then the Gantt chart, whatever written, that will be correct. Now we move on to write the waiting time. So waiting time you need to calculate for each process. So waiting time of P1 I am writing now. So start. We have a formula. What is the formula for waiting time? Starting time minus arrival time. According to that, so starting time of P1 is 0 millisecond and arrival time is also 0, and 0 minus 0, it will become 0. 0 millisecond. I can say like this. Similarly, follow with the P2. P2 also starting time is minus arrival time is 1. So 24 minus 1, it will become 23 milliseconds. Similarly, you can write for P3, same formula, arrival time, starting time minus arrival time. Starting time of P3 is 28 milliseconds. Minus arrival time is 2 milliseconds. So it becomes 36 milliseconds. Similarly, for process P4, the last process in the table. So arrival starting time is 34 minus arrival time is 3. It's already in the table. So 34 minus 3, how much? 31. Now you can calculate average waiting time. Is nothing but number of processes, total number of processes divided by is nothing but waiting time of each process divided by total number of processes. So you can calculate. I will write for your easy reference. The average waiting time is equal to 0 plus 23 plus 26 plus 31 divided by 4, because total number of process in this example is 4 process. Okay, so you can calculate that. That will become average waiting time. So it is 56.7. Hello? Hello? 3 o'clock close. ತಗೊಳ್ಳಿಲ್ವ ನಾ ಹೇಳದ್ನಲ್ಲ ಆಗೋಯ್ತಲ್ಲ ಟೈಮ್ 3:30 ಟೈಮೇ ಆಗೋಯ್ತಲ್ಲ ಕೊರಿಯರ ಬಿಡು ನಾನು ಕಳಿಸ್ತೀನಿ ಜಯನಗರ ಹೋಗ್ಬಿಡು So once you calculated average waiting time, next we need to compute the turnaround time. TAT, turnaround time of the process. We have a formula for this. So for readability, I'm writing this as TAT. So TAT of process 1. Okay, is equal to, here I will write the formula. So waiting time of processes, okay, plus bus time given in the table. So we can calculate TAT1. So what is the waiting time of P1? We calculated 0. What is the bus time? 24 millisecond. So it will become waiting time is 0 plus bus time is 24 millisecond. It will become 24 millisecond. Like this, you need to write for the remaining process. So TAT of P2. Again, same thing. Waiting. What is the waiting time? You computed 23 millisecond plus first time is 4. 23 plus 4. So 23 plus 23 plus 4. So it will become 27 millisecond. Again, TAT of next process is P3. Similarly, you can calculate. So what is the waiting time for P3? 26. What is the bus time? 6. So 26 plus 6. What's the answer? 32 milliseconds. The last process is P4. So similarly, you continue that we calculated waiting time is 31 millisecond. 31 plus 8. So it will become 39 milliseconds. After calculating this, once you can have average turnaround time is equal to, so turnaround time of each process divided by number of processes. So 24 plus 27 plus 39, sorry, 32 plus 39 plus 39. So divided by into number of processes 4. So you can calculate. So the answer will be 92.75 millisecond. So guys, like this you can calculate. So here in scheduling technique, first you need to understand the approach of first come first serve. Whatever the process coming to the system, that will be allocated with CPU, and which is not preempted, it will continue the execution till the termination. Once it terminates from the system, other process or next process in the ready queue may get the opportunity. So this is the example we taken. Thank you.